Hi, this is a 4G Wi-Fi dongle. The dongle only supports 4G and GeoSIM. In some of my area, we have less range and some range issues. To improve the performances of the GeoFi, I removed the inside antenna and I developed three antennas. In this video, I am benchmarking three antennas and checking the performance of these three antennas. The GeoFi supports three bands: Band 5, Band 3, Band 40. The Band 5 supports 824 MHz to 894 MHz. So in Band 5 there is total 25 MHz bandwidth. In Band 3 it supports 1.7 GHz to 1.8 GHz. So there is total of 75 MHz. In Band 40 it supports 2.3 GHz to 2.4 GHz. That's total of 100 MHz. More bandwidth means more data rate. So we are developing Band 40 antenna for this benchmarking.
This is the internal structure of the GeoFi. I removed the internal antenna of the 4G and connected one SMA cable. I will tell you in the later videos how I did. I removed the internal antenna matching component and I connected a 50 ohm SMA coaxial cable directly to the by 4G antenna. You can see there is one more another 4G antenna. In this case I am not using this 4G antenna. I tried connected two antennas, still I didn't get any speed. There is one Wi-Fi antenna you can see in the top side. So this is the internal view of the 4G Wi-Fi dongle.
In this benchmarking video, I'm using three antennas. One is a patch antenna with coupled elements, and the other one is a Yagi antenna. It's a planar antenna, and the third one is a CAN antenna. These three antennas are working in same frequency band. That's band 40, that is 2.3 gigahertz. I'm connecting these three antennas separately to the GeoFi and test the network speed using the speed test. Let's begin the test using the GeoFi and connecting the three antennas separately to the GeoFi. So first I am going to connect the coupled patch element antenna. From my experience, I found out the 4G mobile tower. So I am connecting this coaxial cable to antenna coaxial cable. The antenna connector I extended using one coaxial cable. So this cable is directly going to the 4G module inside the GeoFi module. In this section we will check with this antenna. So it's a so this is a patch antenna with the different directive elements. So this directive element concentrate the electromagnetic fields to the this patch element. So this antenna we are using. From my experience, I found out that there is one tower. There is a one geo tower there, but we don't have that much range. So first section I will test this antenna and check how much speed we will get. So first I connect the cable to coax cable to the GeoFi. Then I connecting to the antenna actually. Yeah, it's switching on. Place it here. Come on. So this is the one antenna. This one is a GeoFi. So the GeoFi has a Wi-Fi. We are connecting the Wi-Fi to the GeoFi. Then I'm using my laptop. I will check how much signal is received. I connected the GeoFi to the laptop. Then I opened the internal details of the GeoFi. From this we can see that the band is 40 and it has a bandwidth of 20 megahertz. It's very important, and it has a signal to noise ratio 2 dB, and the received signal strength is -107. These are very important factors for the performance of this GeoFi. So we can check the internet speed by using the speed test site. So from the speed test you can just, so maybe the first time it will give a less internet speed, because actually the system is actually just connected. So in 4G they have some protocol, so they will do some power adjustment, and it takes some time to get the first speed test very correctly. So I am from the first speed test I'm getting zero point 0.5 mbps roughly, and it has a ping time of 78 millisecond. So yeah, it has a very good uploading speed. Commonly in 4G the uploading speed is very less compared to the downloading speed. Anyway, we can do the test again to confirm these results are correct. In 3 antennas I will do the test result repeatedly, so that I can check whether the my antenna is giving correct result all the time, because the reflected signal is also very important in this antenna performance. So now we can see that the downloading speed is increased up to 5 mbps, and the ping time is also reduced, so it's very good. 6 mbps is very good. Actually, without any external antenna I'm getting very less speed, less than 1 mbps. It never connect to band 40. We cannot adjust the 4G dongle to connect only band 40. So because of this antenna I'm always getting the band 40. We change the antenna to the planar Yagi antenna, so it's a balanced dipole antenna. If we place an antenna outside, and it should be a balanced, otherwise static energy will create a problem. And it has some dielectric, means some reflective elements. I placed one FR4 below the these dielectric elements. So actually this substrate is all these directive elements. 3 4, so it has an 8 number of directive elements. So whenever the directive elements is increasing, the gain is also increased. So I am placing this antenna. First I am removing the coupled patch antenna, then I am placing the Yagi antenna. So this Yagi antenna is a 50 ohm antenna, so this cable is also 50 ohm. I matched this antenna to 50 ohm. So in the TV antennas are not 50 ohm, it's actually 75 ohm antenna. So I made some balloon structure and to match the antenna to 2.3 gigahertz. So so this antenna has no connector, so the cable is directly soldered to the antenna. So it has a, this cable is now I'm connecting to the GeoFi directly. So the polarization is linear polarization. The coupled patch element is also a linear polarized antenna. I'm switch on the GeoFi, then connect the laptop to verify the performance. Now we can check the performance of this Yagi antenna using the laptop. So it's connected to band 40, and it's a TDD, and it has a bandwidth is also 20 megahertz. So it has a good signal strength is -102 compared to last one. Then signal to noise ratio is also good. So we can do the test and check whether the performance is okay or not. So we can do the first test. So from the first test, let's see, it has a less ping time, that's 69 compared to last one. So it has a very high data rates, 11, it's near to 12. 11 is a maximum, we can consider 11 is a maximum for this benchmarking. So it's very good speed. Let's do the test again, because I said it's a 4G dongle. So there is some protocol running in the 4G to adjust the power, and the reflected signal is also very important for this performance. So this is a first test. you can rerun the test and whether check whether this received signal quality is repeatable. So I'm doing the test again. Yeah, it's very good ping time. So now the speed is reduces. There may be two chances that the reducing in the speed. One is the reflected. Now I'm going to change the Yagi Udda antenna to CAN antenna. This is a CAN antenna I made using the copper sheet. So it's a lambda by 4 reflector actually. So there is a one CAN is also due to the shape it got that name. So I'm gonna connected the CAN antenna to the Geofy. So this CAN antenna is a one monopole actually. So there is one monopole is radiating due to the lambda by 4 reflected. The reflected signal is adding to the signal that's coming from the monopole. So totally it has higher gain. So it's very directional antenna. When there is a monopole inside, I think, yeah, there is one more monopole inside, difficult to see. Then we can do the speed test. Its operating band is band 40, so it has 20 megahertz bandwidth, and it has a signal to noise ratio is 1007. It has a received signal is minus 104. So compared to last, this has much signal to noise ratio. So I think this has the maximum power. The signal to noise ratio is directly proportional to the data rate. So it has a ping is a 64. It's also very good. Yeah, we can see that the data rate is increased up to 16, up to 17 Mbps. It's a very good antenna. From this antenna we can get. So one more things we also take in account. I am doing the test at the noon time, so the temperature is very high at the outside. When the time increases, the temperature inside the power amplifier is also increasing. So what happened, the noise figure is also, noise in the power amplifier is also increasing. That will give some bad result, but from this we can see it's a very good antenna. The problem of this CAN antenna is the internal monopole is not connected to the outside, so static energy may create a problem. So when I connect this antenna, I put a tape outside the CAN antenna. From the coming videos we can see how I made these three antennas and which antenna is good for different purpose.